Hello IS pilots, and welcome to IS Flight Training. Lesson 1, where you will learn to fly straight and level, do climbs and descents correctly, and trim out your plane. We will be flying the stock Piper Archer using 50% fuel. Couple of facts about your new airplane. The Piper stalls at about 45 knots. Takeoff speed is 65 knots. Climb out speed is 75 knots. Cruise climb speed is 100 knots. You will cruise at 75% power. Final approach speed is 70 knots and maximum flap speed is 100 knots. Let's start off with some theory first. In order to remain in an unaccelerated, straight and level flight, we have to create an equilibrium of forces. There are four forces attacking the center of gravity of an aircraft, divided into two pairs of counteracting forces. The weight is pulling the aircraft straight down, counteracted by the lift created by the wing. Any body traveling through the air produces drag, which is opposed by the thrust force created by the engine. When cruising, we use a certain amount of thrust. In order to accelerate the aircraft, we have to use some of our excess thrust by advancing the throttle. The aircraft will now accelerate until the drag once more matches the thrust. Now let's see how a plane reacts in a climb. As you can see, the weight force still points straight down, while the lift force has turned with the airplane. In order to solve this problem, we have to split the weight vector into two separate vectors, W1 and W2. Note that the lift force is equal to W2 now, not the total weight force. We now have to find the counterforce to the weight. This is achieved by using the lift vector to cancel out the W2 force, and another force that is opposed to the W1 force. Do you remember the excess thrust we used in straight and level flight to accelerate the aircraft? Well, here it is again. It is the actual amount of power we have to add to climb the airplane. When you think back to straight and level flying, two forces are still missing in this picture. Let's not forget them. Drag and thrust still exist, drag produced by the airspeed a plane has, and thrust being the force to counteract only to the drag. The total thrust cancels out both the drag and the downhill part of the weight force. With all these forces, we once more created an equilibrium. Now let's have a brief look at descending. When in an unaccelerated descent, we have quite a similar picture, but with one major difference. The downhill portion of the weight now acts with the thrust, rather than against it. So in order to prevent the aircraft from picking up speed, you simply have to cut back on the throttle, so that sum of the downhill force and thrust equals the drag. There is one big difference between flying straight and level and climbing or descending. When in straight and level flight, you use the elevator to control your altitude, while using the throttle to control your speed. The next information is very important. When climbing or descending, you use the elevator, your pitch control, to keep a certain speed, while you use the throttle to control your rate of climb or descent. Using the Piper as an example, a climb would look like this. Apply full power, then pull back on the controls to keep the speed at 100 knots. Maintain this power setting while adjusting your pitch, not your power, to stay at 100 knots. Same story with descents. Cut the power and lower your nose to maintain 100 knots. If you want to lower your rate of descent, just add some power and pull up slightly. As you see, the speed is still the same, but the rate of descent has reduced significantly. This may all look very complicated, but the practical part is quite easy. Just practice flying straight and level, and do some climbs and descents at different power settings to get a feeling for the plane. In the next part I will show you how to use the elevator trim, which makes flying even easier. The good news is, not only do you trim your elevator, you also trim your speed. How do I mean this? Now, once you trim out your plane in straight and level flight, you trim that plane for exactly that speed. Every change in airspeed will force the aircraft to make certain actions to stay at that speed. Here, the aircraft is trimmed out at 100 knots. The autopilot is engaged, so I can move the mouse to show you the artificial horizon, which shows straight and level flight, the airspeed at 100 knots, the altitude of 2000 feet, and our rate of climb indicator or variometer that shows zero rate of climb or descent. When I now disengage the autopilot, note that the mouse pointer and therefore the controls remain centered. I'm flying hands-free, so to speak. Now let's add some power. See what happens? The nose starts to raise and we are entering a climb, while the airspeed remains the same. Now let's slowly pull back on the throttle. The nose starts coming down, so that we're now in a steady descent at 100 knots. Any change in the power setting will result in a change in the rate of descent, not airspeed. Note that the airspeed fluctuates around 100 knots, but if we keep that descent for a while, it will keep 100 knots and a steady rate of descent. So here's the summary for today's lesson. When you're leveling off for straight and level flight, set your cruise power, wait for the speed to balance out, and then trim your plane for that speed. When climbing, set your climb power, then pull up the nose to maintain at climb speed. When descending, set descent power or cut the throttle completely, then lower your nose to maintain at descent speed. Always trim your plane for the speed you want to hold. That way you can let the plane fly by itself, while you only have to do minor adjustments. That's it for today. The next lesson will introduce you to the different ways to turn an aircraft.